So many times we have a poorly characterized site where we know we have high contamination, but we have low confidence about where exactly um, that contamination is distributed on site, and we need to sort of delineate an affected surface area. We can use the tools in the EVS software to help us guide where we should place additional samples such that we reduce the amount of uncertainty on site. And in this exercise, we're really less concerned about what the Krieg values are for our analyte. In this case, it's VOC. We're really more concerned about reducing the amount of deviation on site, so we can make an objective statement about what we know and what we don't know on this site in terms of contamination. So right here, and again, we're really only creating this in two-dimensional space for right now, and you can see that we can look at our range of predicted VOC values based on the data we have. We can look at where our highest confidence is in this surface, and of course that corresponds to where sample locations are. We can also look at where we have our highest level of uncertainty, which right here for this data set is about 8.17. And this measure of uncertainty, it's unitless. It really only has meaning when looking at this data set for this site. It is, however, an important measure to pay attention to, and I'll show you why in a few minutes. So now we're going to briefly look at areas, and I'm going to go ahead and subset our plume by about 0.1 milligrams per kilogram, and just sort of take a look at what the affected area would be, what we're going to call the nominal area. And you can see that that's about 368,000 square feet. We can also report the area for the minimum size of our plume with a 75% confidence, as well as what the maximum size of that plume could be at a 75% confidence level. So at this point, with our current data set, we can say that with a confidence of 75%, the superficial plume area is most likely 368,000 square feet, but it could be as small as 187,000 square feet or as big as 553,000 square feet. And you'll see by our measures of deviance that that's quite a wide spread. So we want to be able to be more confident about what we can say about this plume, and using drill guide will help us to address that. So I'm going to go ahead and have the software place samples based on uncertainty in the model, and right now it's going through and placing 30 samples, and you can see that the Krieg output changes with each iteration of a sample being placed. It's also worth noting that you can also guide where samples get placed. So if you have an idea of where you want to put locations, you can place those in the software and then evaluate how that changes the delineated plume area. I'm now going to go back and calculate area after we've run this procedure. So this is the nominal area, and this is our minimal area at our 75% confidence level, and our maximum area at that same confidence level. It's also important to note the reduction in uncertainty when moving forward via this method. So in this example, really the take-home message, one of the most important things to take away from this is that this method really allows us to reduce the amount of deviance when we are proposing new well locations and saying something about that effect on delineating a plume area.